Okay, so this is our first example. We're going to prove by induction that for all positive integers n, 1, minus 1, 0, 2, all to the power of n is equal to this. So it's exactly the same process. We start with our first step, which is when n equals 1. Now for this one, we need to show that the left-hand side equals the right-hand side, okay? So if we start with the left-hand side, we're going to have 1, minus 1, 0, 2 to the power of 1, which is obviously 1, minus 1, 0, 2. Okay, and then if we do the right-hand side, remember all the n's are becoming 1s, so we've got 1, and then 1 minus 2 to the power of 1, 0, 2 to the power of 1. Hopefully you can see on this one, the 1 and the 0 obviously staying the same. And then 2 to the power of 1 is 2, so 1 take away 2 is minus 1, and 2 to the power of 1 is 2. So we're showing there that the left-hand side does equal the right-hand side. So true for n equals 1. As always, yeah, first step is always when n equals 1. So then, second step is always the same. Assume true for n equals k. And so, coming back to our question, we're just going to replace all the n's with k's. So we've got 1, minus 1, 0, 2 to the power of k equals 1, 1 minus 2 to the power of k, 0, 2 to the power of k. Okay, so that's our assumption. Assume it's true for n equals k. And then the next step is always the same. It's when n equals k plus 1. Now remember, with this one, what we're eventually going to need to try and get is that all the k's become k plus 1s. Okay, so the way that we approach this is we start with the left-hand side, replacing the k with a k plus 1, and then we're going to try and work with the left-hand side until we get to the right-hand side with the k's being k plus 1s. Okay, so if we start with our 1, minus 1, 0, 2 to the power of k plus 1, okay, we want to work with this to get to this plus 1, with all the k's being k plus 1. Does that make sense? So, a bit like the last example we did with our rules of indices, because this matrices, or matrix, is to the power of k plus 1, using rules of indices, are you happy that I can put the matrix to the power of k times the matrix to the power of 1? Because the rules of indices work in the same way. Okay, so we can write this as 1, minus 1, 0, 2 to the power of k times by 1, minus 1, 0, 2. Yeah, does that make sense? Now this is what we had here. So I can now replace this with the right-hand side of n equals k. Yeah, because this is basically our assumption for n equals k. We're going to substitute that now. So we're going to have 1 minus 2 to the power of k, 0, 2 to the power of k, times by the 1 minus 1, 0, 2. Are we okay with that? And then we're going to multiply out our matrix, our matrices. Okay, we're going to actually multiply these together now to see what we get. So, are we all happy when we're multiplying? Remember, when you multiply, you're adding. So we end up with, what have I got? Let me do it as one big matrice. I've got 1 plus 0, and then this is going to be minus 1 plus 2 times the 1 minus 2 to the power of k. biggest one that I've got to fit in. And then 0 plus 0, and 0 plus the 2 times the 2 to the power of k. We happy with that? So if we simplify that, obviously we've got a bracket here that we can just sort of expand out a little bit. I've run out of paper. So if I just put that, I can fit it in, put that there. So we've obviously got 1 add 0 is 1, and the 0 add 0, so that left hand side of the matrix is quite easy to do. And then here we'd have minus 1 plus 2 minus 2 times the 2 to the power of k. And then here we've got the 2 times the 2 to the power of k. So again, simplify the numbers there. I've got 1, 0, 1 minus 2 times 2 to the power of k, and that's 2 times 2 to the power of k. We okay with that? Now remember, what we're trying to do is get everything from our original, if I write it here on the side because I can't fit it in on the screen at the top, our original right hand side, we want all the n's to be replaced with k plus 1s. Now again, this is working backwards from what we just did earlier. If we think of our rules of indices, this technically is 2 to the power of 1 times 2 to the power of k, and this is 2 to the power of 1 times 2 to the power of k. And what do we do to the powers when we're multiplying indices? We add them. So we're actually done, because if we write that as 1, and the 0 are alright anyway, as 1 minus 2 to the power of k plus 1, and this would be 2 to the power of k plus 1, this shows that it's true for n equals k plus 1. So therefore true for n equals k plus 1. Yeah, you happy? We've replaced all the n's with k plus 1s. Okay, and then we finish in exactly the same way. So if true for n equals k, then also true for n equals k plus 1, as true for n equals 1, then true for all positive integers n.